All right, great. Okay, so you're being recorded, everybody. So good evening, and it's time for us to get started. Um, and just from a scheduling point of view, Linda and I, worked out a plan. And so when she leaves, I am the moderator, and so and she does have appointments that are happening later this evening, and so she'll kind of go around 7 o'clock. But that's fine because we have a plan for that. And this is September 1st. Okay. And some people call this the end of summer. And in fact, I will tell you that Panera Bread calls it the end of summer because there's a summer salad my daughter really likes, and I stopped to buy it, and they say, "Oh, but it's not summer anymore." So we didn't get that. But anyway, okay. So I'm going then to this slide, and as sort of is our custom, I'm going to talk for a while. Here, and this is my these are my talking points, and so I'm going to speak to these points a little bit. Linda, you have a slot after that, and students, I will ask you for questions and answers. Now, if you have a question before we get to the question and answer, again, your questions are always welcome, so you're welcome to ask those kind of questions. So you certainly can ask your questions and just either shout them out or raise your hand or something like that. Okay, so I'm going to just begin talking. And by the way, one of the things I want to stress about the book is that Linda had estimated that less than 25% of the book, of the people in this course in the past, actually bought the book. And I think Linda probably has a pretty good handle on that. Again, I haven't done a detailed counting, and I actually invested considerable energy over several years coming up with this ebook that's available, and it's gotten kind of screwed up every year, and it was screwed up again this year. I've invested an enormous amount of my time, and I'm never going to get that time back. But I have been investing that for those students who went ahead and bought the bookstore thing, even though I sort of said, hey, wait on that, you might not want to do that. So I am continuing to pursue this. And after talking to 6 people, I'm finally, and I'm not talking, but I am exchanging email with someone that knows what they're talking about. And so that is progress. And they sort of said, oh, it can work like this. And I sort of demonstrated to myself and to them that it can't work exactly like that. But we're making progress because after working through 6 different people at Pearson, I'm finally talking to someone who knows what they're talking about. So that's progress. And someday soon I will, announce the availability of the book and things like that. And maybe 25% of you may, buy it. But anyway, I've actually been working very hard on this. And I asked Linda if she wanted to do it, and she said, hell no. So Linda didn't want to touch this with a 10-foot pole, but I am working on it and things like that. Okay, so the book, I'm continuing to work on it, and I was sending emails with this person today and everything else in between teaching my classes. Okay, so that's the story. There is a book update, and I think I can report, actually, for the first time ever in this course of ours, I can report genuine progress. Okay, so that is good. Okay, LSA slots. I have established LSA slots for you to do an answer sheet and a PDF upload. And Linda, I would like to ask you, and Linda, if I'm asking you to do something that's like really hard, you can tell me that's impossible. But what I'd really like to do is show students this. And so, and I know I made a video, and one student said the video was helpful. But anyway, Linda's going to Blackboard, and Linda's going to show you both VCM and NET. Okay, so Linda, you want to be, all right, so Linda went and she clicked on, what did you click on? The answer sheet?
So yeah, I went down to the LSA answer sheets. So you just click on that. It's going to start almost like it's an exam or something. You just type in your answer.
And that's the answer sheet. Now later, what's going to happen is this is going to be where you're putting your answers for the high stakes assessment. So that's why we're practicing this. So when you don't get to that point and say, oh, that's horrible. And you see, you can, and Linda's also showing you that, gee, I'm letting you save this. So you might go in and start to do it, but then you say, oops, I think my answer's wrong. And then you can go back and put your answer in again. Okay, so and there is a thing at the end where you can submit it. Now this is the primary grading instrument, okay? And so, and this is going to be the primary grading instrument for the high stakes assessment also. And Linda and I haven't rehearsed this, so Linda, if I ask you a question that you don't want to answer, just, tell me. But Linda, what do I mean about the primary grading instrument, do you think?
So you're going to look at the answer first. If the answer is correct, then great, full credit, just kind of skim through the work and make sure it looks good. If the answer is incorrect, then you're going to go to the PDF and see how much partial credit you can give them.
Okay, so you see, answers matter. Okay, now Linda, I would also like you to show the the PDF upload thing as well, if you will, please.
Okay, so I'm just clicking on the PDF uploads link at the bottom. And you can browse all your files, submit things. I'll send Bradley his own PowerPoint.
Okay, thank you, Linda. Okay, so anyway, those are there. And Linda, you don't have to demonstrate this, but could you please go to the Net 1 course, or the net class, yes, and just show them that the same stuff is there for them.
Yeah, so when you scroll down, you do still have the LSA answer sheets link and the PDF uploads. And if we go under there, then we do have LSA 1 available, as well as the PDF upload for it.
Okay, and in the video, I recommend, I have no stake in this, it's a free app, but it's actually a pretty good app, and Linda can show you other apps and you can find your own app, but I do want you to be uploading PDFs. And I am going to say, and I say this in the video, it's important, I think, for students to practice this, because I don't want you coming to the high stakes assessment and saying, well, how the hell do I do this? I want you to have practiced it. And so that's why I'm really asking you to do this. So if you slid your answers underneath my door, or if you mailed them to me in the United States Postal Service, or if you emailed them to me at bradley.cod.edu, I'm going to ask you to go back and do it this way to practice them. And Linda, who is very much a student advocate, and that means she is she talks about you in positive terms all the time, and she doesn't let me do anything cruel to you. She said, well, why don't you give them some extra time? And so I extended the date a little bit for that, and there's no late penalty on this first LSA. So anyway, all that's in the video that I sent you that I hope some of you watched, okay? But I kind of went through this, but Linda now has shown you in real time. And again, if people have some questions on this, they can ask them later, because there's going to be the student question and answer thing. Okay, so Linda's going back now, I think, to the PowerPoint. Oh, here's something that someone asking it. Linda, did you see that chat?
Yeah, we did go through an example really quickly. All you're doing is just attaching a file, just like you would when you're trying to upload anything.
Okay. And again, that chat came up quickly, and I didn't stay on the chat, but I think Linda, made a good faith effort to answer that question, and we're just going to pretend that that is answered. Okay, so we talked about the book update. There is genuine progress. We're not there yet, but damn, I haven't had genuine progress for a long time with these guys. So there is genuine progress now, because I am talking to someone who knows what they're talking about. And it took 6 people to get to that person, but we're there now. That's good. Okay, we've talked about LSA slots, and then you all know that there's an LSA 2 out there, and there's a video on that, and that's not due for a while. And so, but you want to probably be working on that sometime. And that's all I'm really going to say about that. I have not gone and made the LSA 2 slots, because actually it takes me time to do this, and this often isn't my there. But Linda also will remind me, and in fact, she sent me a note the other day, a text, and she said, set up the answer sheet and PDF upload. And I misinterpreted that. I thought she said, "Oh, Jim, I have already set up the LSA slot and the PDF answer." And then when I thought about it for a while, I said, "Oh, maybe that wasn't what you meant. Maybe you were reminding me that I should do this." And Linda said, "Yes, I was reminding you that you should do that." So anyway, that will
I'm good,
happen.
but I'm not that good.
Well, no, Linda. Actually, Linda is very good. In fact, Linda is. Not better than you deserve, because you deserve the best, but Linda is among the best, okay? There are 2 tutors that stand out, and I actually work with both of them, and Linda is one of them, okay? And the other one is a man by the name of Jesse Hayes Carver, and he also is outstanding. Okay, so anyway, we're good with that, I guess. Now, Labor Day. We have this class normally meets on Monday, but Labor Day is a day off from the College of DuPage. Now, I'm going to tell you the truth. I'm going to be doing math on Labor Day. I might be sending you videos to look at on Labor Day, and you can do math on Labor Day. And I have no idea if Linda's doing math on Labor Day, but you don't have to come to this class, because there won't be this class. But I'm going to be doing math, and so you can do math, and I'll send you things. We're not going to have anything due on Labor Day, but there's not going to be a class that day, just because the College of DuPage doesn't do that. Okay, I have one more thing that I want to tell you about, and this actually has become a more serious issue, okay? And I used to think when I was young, and in fact, I think it was true, well, younger, I used to think that there was no consequence here, and there used to not be a consequence. What they do is the College of DuPage says, we will have a 10th day roster verification. And I'm being very honest with you, I viewed that as kind of a pain in the ass. And I asked people back in the day, I said, well, what happens if I say a student isn't attending class? Or, you know, I don't know of that student. And what they used to say is, well, we might send that student a letter and say, hey, remember you're enrolled in this class and you ought to, you know, start going to it and things like that. And I said, did it matter? And they say, well, the student might get a letter. And I said, yeah, but nothing else happens. And that was the way it used to be. There's a song I used to like, and it says, used to be's don't count anymore. And this is true too. They've changed this, and they is COD administration. So not only are they making me fill out these forms, which I always did anyway, but they're saying that someone who I don't say is attending, and actually I think you're either attending or not attending, they've started dropping people from the course. Now, some people have dropped from the course and then wanted back in, and so you can get back in, but that's a big administrative pain in the ass. So you don't want that. But when I say that you're attending, I have some proof of that, because I'm actually signing a form that says, and you can prove that this student is attending. Well, Linda and I don't invest our time taking attendance and who slips out and who doesn't slip out. And by the way, you can't do that for a net course anyway. So my proof that you're attending on the 10th day is when I start filling out these forms, I look and say, hey, have they turned in an LSA 1 or an answer sheet? And by the way, your answer could be completely wrong, And I don't mean I don't care, because I do care. Answers matter, but that's my proof. I look and I say, oh, have these people turned in the LSA to Blackboard? If I see that, I say, oh, yes, they're actively participating. That's an A. And the A doesn't mean an A grade. It just means you are active. If somebody hasn't turned that in, I say, well, I don't have proof that they're here. And so, and again, the consequences are, oh, it's not, it's not doomsday, because even if you get dropped in the course, you can get back enrolled. But I have to fill out forms and stuff like that, and I don't want to do that. I will do that for you, but I don't want to do that. Okay, so there are consequences. So Linda, what's the bottom line takeaway from that whole thing? What should they do with LSA 1?
Definitely submit it as soon as they feel like they can.
That's right. And again, the 10th day roster, they say as of the 10th day, but then they'll just send me nasty emails, for me to do it. And I'm going to be doing this like into next week. So anyway, it's all fine, okay, as long as you do this. But anyway, I really wanted to mention that. Okay, I'm finished talking about all of that stuff. I'm sorry it takes so long, but this is maybe one of the benefits of the, I don't know, of the VCM. Layla has her hand up, so I'm calling on her. Layla, why don't you just verbalize your question, please?
Okay, I have a question. So I'm not in state, I'm in a different state, and sometimes they block me out of Blackboard because you said they drop you off if you don't submit things. I try to submit things, but because my Blackboard gets locked, I was locked for 3 days. I couldn't open my Blackboard or see any of like my homeworks or assignments. It just went
Okay, and
away.
and now the college, and by the way, I could be wrong, but either it's a technical problem that the college has that they should be solving, or there's some administrative problem in your life. And I don't want to even go into that, but that could be like sometimes students have paid, but it didn't get recorded or something. I don't know. Okay. But keep working on that. And I will be, Layla, I will be sympathetic, to your issues as you have issues. But also, when you have issues, if it's a technical problem, you ought to be on the phone to IT. And I told you that phone number, that is 630-942-2999. So they can fix your technical issue. And if you have some kind of other administrative issue, like, I don't know, if maybe a check hasn't cleared or your financial aid's not ready or something like that, talk to the registration office. And again, if you get wrongly dropped from the course, I will work with you, but I'm not in control of this. So, try to make it happen with Blackboard and make it fixed that way. And that's kind of my answer to that. And if you want to come to my office hours, I can talk at greater length with anybody about that. Now, I think Amber, and Amber, you do show up here as Amber, not Steph. But anyway, Amber, I see your hand, so I'm calling on you.
I just had a question about the LSA 2 PowerPoint. I don't see it in the syllabus tab.
Well, Linda will probably tell you I haven't done that yet, but I did give you the video, and I will do it. But also, you can just write things down from the other one, and I'll do it sometime. And you see, Linda will probably send me a text and saying, "Oh, hey, set up LSA 2." And she's not telling me she set up LSA 2. She's saying, "Jim, I'm reminding you to set up LSA 2."
Okay.
So anyway, that'll happen. So I hear you, and yeah, that's probably true. There was, yeah, and somebody's saying there's a video announcement, and yes, there is. In fact, if you watch the video announcement and freeze frame, you can write everything down you need to start working on that.
Okay,
Okay.
I'll pause it. All right, thank you.
Okay, and Linda, I didn't read all of that last comment. Did you see it?
Let's see. Sometimes we have a problem with the Blackboard and then we submit it through email, but that is the opposite of what you should do.
That's right. And the reason I'm doing that is, well, first of all, one of the things I've learned is it's useful to practice this, because I have students who send me literally gigabytes of stuff when they take the test, and they say, I couldn't make board work? Well, my answer to that usually is BS. You were being lazy. But what they do when they send me those gigabytes is they totally jam up my email, and I spend hours doing that. Okay, unclogging my email so I can send a single email. So anyway, Linda, or someone just answered the question. That's good. You're helping each other. Okay, so that's all, I guess, good. Okay, someone answered the question that was asked. Linda, I'm turning the floor over to you.
Okay, so we actually just had a GSG before this, and there were 7 people in attendance. So we're getting awesome turnout on that. Everyone seems to be on the ball with watching the videos, getting the homework done. I did want to send out a quick poll just to see if you guys want the usual GSG on Labor Day, since that would normally be when we were scheduling it. Otherwise, I can push it to another time that week. So depending on what you guys would like, then I can reschedule it if needed.
Okay, Linda, we got
All right.
some. I think you got your answer. And
Yeah,
and by the
seems
way,
like people want me to reschedule. So I'll send out the day and time that that'll be moved to.
okay. And by the way, I think that's actually safe because I'm not having office hours on that day, even though I'm doing math and things like that. And I will tell you that a since retired math person used to have evening classes on in-service day because he, just wanted to do math, and someone got angry at him, actually, at administrators. So anyway, I think we're good with that. Anything else, Linda?
No, I think that about covers it.
Okay, so this is question Q&A, and we had some of that already, and maybe there's no more, but I will count to 10 Mississippis before we do this, okay? I'm going to advance the slides because I know where we're going. But Linda, there will be time, and I'm assuming that that you're okay until I know you have to depart in a bit. And in fact, Linda, in my head, I'm thinking I can work with you until 7-ish, and I will honor that. But are you in a position there with your puppy that you can do some things?
Yeah, absolutely.
All right, so we'll try that. So, okay, so there'll be things I'll probably ask you to do. Here we go. And by the way, these things are in your syllabus tab, and some of these things are exhibits you'll want to look at. So here we go. Okay, now, the video that many of you watched is about a bell-shaped curve. This is called the normal distribution. It looks like a bell. Maybe you think that's not a bell, but it is. There's a center, and I guess I'm trying to point here. I don't know if they can see my pointer or not. I think they can't. So I'm going to go over here and grab the hand. Maybe I can do this. Linda, they can see
Yeah,
my
that should
hand
be
now?
it.
Okay, good. Okay.
Actually, no, I do not see your hand. There should be some kind of pointer tool, though.
All right, I went over there to hand. So where the heck do I get a pointer tool? Maybe Linda will figure out where the pointer tool, and she'll point. The middle of this distribution that's called the center. Oh, I know. Hold on. I figured it out. I bet it's this thing. Can you see that? Maybe I give
No.
up. It says I can draw. Now, let me see what happens. I can't draw. What the hell's going on? Drawing tool. This isn't working for me, but that's okay. The middle of this is the center, and that's the mean, and that's also the mode, okay? And it's also the median. And so in this case, yeah, Linda's drawing there. Okay, so that center thing, that's what we call it. And then this bell, drops off, and it drops in the positive direction and in the negative direction. So anyway, we're talking about bell-shaped curves, and that's the normal distribution. Okay, so now I'm going to the next one. Now, there are tables in your book. And by the way, I actually spent some time thinking about how I wanted to describe this. And so here's what's happening then. The table in your book. The inside body of the tables in the book give you these areas. Okay, so there's a curve, there's a drawing that is on the left of this chart that is at the top of the table. So it's that area that's in the chart. It's the body of the chart. And when we get to those, Linda will remind you, but I'm telling you, you can look at these pictures and figure out what area. And so Linda, this is showing the area from minus infinity up to something called Z. Okay. So that is minus infinity up to Z. And Linda, if you want to circle something or anything like that, feel free. And I'm just going to rely on your good judgment about that. But that is the area. That's one place. There's the Z. Okay. But there's one curve that is for negative values. That's the left curve. And there's another curve for the positive areas. That is the, it's not positive areas, damn it, it's positive Z values that's on that side. But where do you find these numbers? The numbers are areas, and they're the inside body of the table. The book gives you these areas. Now I'm telling you just the facts, but these are important things, I think. And I actually thought about how to tell you this. So in fact, let's don't do a poll. I don't know, maybe. Linda, let's do a poll and ask the students, where are the areas? And one answer will be inside body, and the other one will be somewhere else. We're doing this poll because this is damned important.
All right, just setting it up now.
Okay, good. And Monica, we'll listen to you in just a moment. I'll ask you, but let's look at Linda's poll. Here's the poll. Okay. All right, I was going to say 2 people were wrong, but then Monica said that was an accident. All right, so 1 person is wrong, okay? They're on the inside of the table, okay? So please remember that. And again, we don't know who said this or anything else, so, that's fine. And some of you aren't playing, and I don't know what that means. Okay, but anyway, we'll continue going, all right? So I'm just telling you facts. Okay, now, here is another important fact. I'm just reading it to you. The area, and by the way, these all were in the video, but the videos are pretty terse. You might want to watch them, a second time sometimes. The area under the graph of a density function over an interval is the probability. So area is probability. Probability is area. Okay, we're not going to do polls on all this stuff, but I'm just telling you important stuff. The total area under the curve is 1. The normal distribution is symmetric about the origin. And you should know that there's some very serious math involved in computing the values in that table. But you get to use tables. You don't have to use the serious math. Linda understands the serious math, and so do I, but you have tables. So that's just going to be fine. And you will be fine with this, but you do want to work on this a bit and understand what I'm saying. Okay, so now I'm going to show you the table. And what this says is that I told you that the inside of the table are probabilities. And I'm telling you that the outer boundary of the table are the Z values. And I'm telling you this, that the Z values are standard deviations. Okay, so Linda, perhaps, I know you're annotating this. Do you want to say some things, Linda, about this to help the students? And 7 wants to help you with this too, because 7 is helping us with her comments as well.
She's trying to. So
Okay.
the way that you're finding the z-score, which is typically rounded to the second decimal place, on this chart, then you're looking for the tenths place on the left-hand side here, and then you're picking out the hundredths place along the top.
And we're going to do some examples, so we'll underscore this, okay? And inside the table are the probabilities. And Linda, what area does that represent on this chart? And
So
she'll probably
that is
just go
the
up and
area to the left of the z-score, as we can see in that picture up there.
all right, excellent. Okay, now this chart, and damn it, somebody had their hand up. I don't know if it was Monica or not, and I said I was going to call on them again. So we're just going to we're going to pause here for a minute because somebody had their hand up, and I'm sorry I didn't write that down. I said we'd get back to you. Now you're going to get some practice on this, but my students, if you don't have the book, and you probably don't have the book, you want to have this chart in front of you, and you can make it bigger because it's in the syllabus tab. And so that's where Linda's getting this. And I'm asking, and maybe you're, whoever was asking that question got it answered, but not. I'm going to count to 5 Mississippi in case they want to raise their hand again. I apologize for that. I'm actually better than that most of the time. I think I'm hungry right now. So anyway, I'm counting to 5 Mississippi in case there's still a question out there. Okay, there's not. I'm advancing the slide, Linda. We're going to the next one. And Linda, I'm going to ask you, what the hell is the difference between this slide and the earlier slide?
So on the previous slide, then it's very similar, but the z-scores were actually negative because you're on the left-hand side of the mean. On this, then you're on the right-hand side of the mean. So we end up with positive z-scores. And if you look at the areas in the table, then they're all above 50%.
And Linda, they'll have to use both of these tables, won't they?
Yes.
And Eva, I am going to call on you in just a minute. It's Eva, I'm going to call on. Yes, and we will have these tables in things called grace notes on the high stakes assessment. But you want to hang on to this thing because it will help you do homeworks. Eva, you have a question.
Yeah, so the left side will always be positive and the right side will be negative regardless of how big the area is.
Those two things are actually related, but I'm going to let Linda answer that.
I'm sorry, what was the question? It kind of cut in and out.
The left side will it always be positive and the right side will always be negative regardless of how large the area is?
So the area will always be between 0 and 1, since the area under the curve completely equals 1. And then on the left-hand side, the z-scores are negative. On the right-hand side, the z-scores are positive.
And actually, the next slide, I think, is going to clarify that. Actually, I don't know if it's the next slide or not, but we'll pretend it is. It is. Okay. Now, and by the way, okay, so Eva liked that answer, Linda, so that's good. Linda makes people happy, and I usually don't. Okay, and Linda, that's getting fuzzy, and I don't know, you fixed that the other day. Can you fix that again?
Yeah, so I just need to share my screen instead of the PowerPoint.
Okay, do that. That would be great. Okay, now this is, I think, an important slide. Okay, there is the table that we were looking at, and that's on the right-hand side. So that represents a bell-shaped curve, and that is, I call that Z space because that lives in your book. It lives in the tables that we just showed you, and that is also called the standard normal. And I think I can see Linda spout how to do that, but that's also called the Z space. And it's also called the normal 0, 1. And when I say normal 0, 1, that means that the mean is 0 and the standard deviation is 1. And Linda, I think this is a good answer, a good place for maybe you to comment about whether it was positive or negative, because you got 0 on this chart. And I think this will help Eva. And I know she said, okay, thank you, but I think this will be okay with an exclamation point on it. So can you speak to that on this chart?
Yeah, so you can see on the x-axis down here, which we should probably relabel that as a z, that depending on where you're at, if I have a z-score of -2, then I'm looking at the area right there, if I'm referencing the chart. So I'm still going to get a positive area even though I have a negative z-score.
Okay. And, okay. And I also say, boy, I thought I said this somewhere. The z-scores actually are standard deviations, okay? I really thought I said that somewhere, but anyway, that's okay. Now, there are going to be some problems that are in the real world, not in your table, and that is going to be on the left side of this chart. I call that X space, and these are normal with a mean of mu. That's a Greek letter, that's the mean. And by the way, we talked about that in the video, and I'm talking about it again. And the standard deviation is sigma. Okay, so those don't have to be 0, 1, but in your table they are. And you might say, well, how do we get from the real world to the table and back and forth? And that's in the middle of this. And Linda, in the middle, we've got this arrow that's going both ways, and that works both ways. Now, Z space, that's where Z is. So Z, and by the way, we talked about this in the videos too. This was the standard score. In fact, I think we did some standard score things last time too, Linda. I think we did calculations with those. So this is an important thing for you to know. Z is equal to X minus mu over sigma. Linda, the X is on the left-hand side. The mu is the mean of the bell-shaped curve on the left-hand side, and sigma is the standard deviation of the bell-shaped curve on the left-hand side. And Z is in your table, and it's over there on the right-hand side. Now, there are two great problems that we will be working, and we're going to do some of them. And by the way, we're going to get to doing these problems very soon. And Linda, I'm going to ask you to, grab a hold of these and do chalk talks and things like that. And Linda, that probably means you have to jump back and forth between, you'll figure out how you want to do it. And I'm sure you'll do a good way. What I would probably do, not saying that this would be good, I probably would go to the blackboard and then I jump back to my my normal tables or something. But anyway, we'll have people look things up. But there's two great problems. One is given a probability, that is given an area, find the numbers associated with that. And the other one is the other problem. It is given the numbers, find the probability. Now, later on, I hope some of you will go back and look at these charts again and you'll say, oh, okay, I get it. But we're just going to jump in and start doing problems now, okay? So everybody should have your problems at hand. And Linda, you're sharing your screen, so just advance the slide, please. Okay, now I'm going to read this, and Linda, I'm going to ask you to work a problem. And you don't have to work all these problems, but you'll pick out one that you want to work in problem 5. But I'm reading the directions, okay? In 5 through 12, find the indicated areas. So you see, this is saying I'm giving you a number, find the area, okay? It says for each problem, be sure to draw a standard normal curve because you want to do that. And Linda will show you that, and she'll do that, and shade the area that is to be found. And Linda, which one of these you want to do? And again, Linda, I'm not going to make you do all 4, but do you want to do 5, 6, or 7?
We'll do 5.
Okay, 5, and I'll let you pick one of those to do, or maybe you want to do 2 of them. Maybe you want to do a negative and a positive. And I will leave it to your good judgment what you want to do here.
Yeah, that sounds good. I think I'll do B and C.
Okay, B and C, that's actually, I would have chosen those as well. And I'm also going to say something about B and C. Linda, is this problem in Z space or is this problem in X space?
So we're starting with the Z-score, so this is in Z space.
And that's why there's a Z there, and that's why Jim calls it Z space. I hope that helps students. The intent was for that to help students. Okay, Linda, it's all yours. So talk through this, please.
All right, so I'm going to start with B. There we go. So in this one, we have Z equaling negative 0.43. Now I'm finding the area to the left of this, so I'm going to draw my curve first. And it doesn't need to be perfect, just a rough estimate. Now, if 0 is my mean, then negative 0.43 is going to be slightly to the left of that. So this is about negative 0.43. And then the area would be the area to the left. So now if I go to one of those charts, then I'm finding where the Z-score is negative 0.43. Now, if I look at this one, my Z-scores are positive. So I don't want this chart, I want the other one.
And Linda,
Now,
we're not
I'm gonna
seeing,
need to
oh,
zoom
okay,
in.
there you go. There you go. Okay, thank you.
Okay. So I'm zooming in a little bit and I'm going to negative 0.4 and then I need to go over to 0.03. So that's going to be this column and negative 0.4 gives me 0.3336. So I can zoom back out. And that would be my answer.
And Linda's probably going to poll for questions, but if you got questions about what she did, you should ask them now. You will have access to the tables, yes. And Amanda's question, the answer is yes also.
Yeah, we're going to go through another problem.
Okay, and maybe that was asking Eva. So Eva asked, well, okay, I think Linda just said, yeah, stay tuned and you'll see that again. Okay, Linda, you're doing C now?
Yep. So for C, then I have a Z-score of 1.35. So I'm going to draw another picture so I can get a visual of this. If my mean is at 0, so that's where the high point is, then I'm going slightly to the right, a little bit more than what we had before. So something like right there. And then I would be shading the area to the left. So that would be all of this.
Because the problem told her to do that, yes.
Any questions on that so far?
No, thank you.
Okay, great. So then if my Z-score is 1.35, I'm going to go back to those tables. And now because I have a positive Z-score instead of a negative, then I'm going to use the one on slide 7 instead of the one on slide 6. Slide 6 has all the negative Z-scores. Slide 7 has the positives. So I'm finding 1.35. So I'm going to zoom in a little bit. Now 1.3 would be this row right here. And I want to go over to where I have 0.05 to get that hundredths place. So I'm finding where that row and that column intersect, and that's going to lead me to 0.9115. Can everyone see how I found that number?
Monica answered for the group and some others. Yeah, a whole bunch of yeses here. This is good.
Okay. So then 0.9115 would be my answer here.
Okay, now Linda, I know I threatened to say just do one of these, but I think 7 actually is different. So could you pick
Okay.
out one of those in 7 to do and make sure that the students understand what's different here?
Yeah, so on 5 and 6, then they're asking for the area to the left, which if we go back to the diagrams, that matches the picture that they gave us. So we didn't need to worry about doing anything fancy because the area given in the chart was already the area to the left. But if we're finding the area to the right, then we need to change this up a little bit. So I'm going to do, I think B would be best. So if I'm drawing my picture here, then my z-score is negative 1.59. So again, that's going to be slightly off to the left, right? Now, since I'm finding the area to the right, though, then I need to be a little bit clever about this. My charts only give the numbers for the area to the left. So the area to the left, if my z-score is negative 1.59, well, let's go back to our negative chart. Zoom in a little bit. So negative 1.5 is right here, and then 0.09 is all the way at the end. So when I find where those intersect, then I get 0.0559. Now I'm going to take that number, but that is not my final answer. That was 0.0559. Yeah. So here's where you need to remember that the area under the curve for the entirety of this equals 1. Okay? So
Hey,
we're
Linda,
going to do 1.
Eva asked also, why did you use 0.09?
So I did 0.09 because the hundredths place here has a 9.
Okay, she's good. That's great.
Okay.
Thank you, Linda.
So because the area under the whole thing is 1, and I know that the area in the small tail that I didn't color in is 0.0559, then I can subtract that from 1 and get the area to the right instead of the area to the left. So that's going to give me 0.9441. And that would be my final answer for the area to the right of that z-score.
Okay. That's great. Linda, would you please advance the slide? Now, I said that there were 2 great problems, okay? And the 2 great problems were given a number, find the area, and that's what we've been working on so far. But there also are problems that, that doesn't really go there. So I guess, Linda, I'm going to suggest, why don't you go to problem 9, which is different. And I was trying to go somewhere else, but I'm trying to go too fast. And I don't know, Linda, you can do 9 or 10 or 9 or 10. Pick one of those and either do A, B, or C. Something there, please, Linda.
Yeah, for sure. Let's do 10C. So if I'm looking at this problem, then I'm actually going to break it up into 2 separate pieces. Because what they're asking me to find is the area between 2 z-scores. So that would be negative 3.03 and positive 1.98. So that's about where on the curve those would lie, and the area between these would look like that. Is there any questions about that picture I just drew? Okay, I'll take that as a no. So to find the area between these, then I'm actually going to break it up into two pieces. First, I'm going to find the area to the left of that 1.98. And then once I get that, then I'm going to subtract off the area from that negative 3.03.
So Linda, you're sort of this harder problem you're doing as two easy problems, yes?
It is.
Yeah.
So going back to my table, let's find out what the area is to the left of 1.98 first. So I go down to 1.9, I go over to 0.08, and I'm getting 0.9761. Can everyone see how I got that number?
I'm seeing some yeses. This is good.
All right. So 0.9761. And then I'm going to subtract the number that I get from finding the area to the left of negative 3.03. So I'm going to go to my negative z-score table and find negative 3.0, which is right here. And I'm going to go over to the 0.03, and that is 0.0012. Everyone good with that number?
Lots of yeses.
Okay. So minus 0.0012. So then from here, all you're going to do is just go through and subtract real quick.
And Linda's doing that the old-fashioned way, but you also will have access to Excel. So you could do that with Excel if you wanted to.
So my final answer ends up being 0.9749.
Okay. That is excellent. And Linda, I'm being very mindful of your time. And so what I would like for you to do is advance the slide, and we'll do something more complicated. And Linda, these things down here are, why don't you do one example of actually, okay, let's go to the, let's just do number 15, okay? Now 15, you all remember that I said there were two great problems. Now so far Linda has said, oh, given a number, what's the area? But now she's doing something different. And Linda, I don't care if you do 15 or another one, but I do one of those
No,
up
15
there.
is fine. So they're
Go
saying
for
that
it,
the
please.
area to the right is 0.25. So if I kind of draw myself a picture of this real quick, that means that this chunk over here has an area of 0.25. Now, if we think of our charts though, they give us the area to the left of the z-score. So I'm actually looking for a number inside the table that is not 0.25, but 0.75, because that is 1 minus 0.25. So here, that is how I get that 0.75. That is not the z-score. That is the number inside the table for the area that I'm using to find the z-score. So I'm going to go back to my positive table over here, since this has the one with all the areas over 50%, and I'm looking for 0.75. So I'm going to zoom in a little bit, and let's see how close we can get to that. Now I'm just kind of skimming through this table, and I see 0.7486 right there. The next one is 0.7517. So it would be somewhere between those two. Now 0.7486 would be 0.0014 away. 0.7517 would be 0.0017 away. So I want to go with the one corresponding to the 0.7486, since that would land me closer. So looking at where those line up to, then I'm getting 0.6 on the left-hand side over here and 0.07 on the top. So my answer would be 0.67.
Okay, and let's see, Linda, I'm still, doing this. Could you do, well, no, actually well, all right, we will do one of these. Now those Z sub things, Linda, those are percentiles. So could you do one of those from 19 to 22? And again, I am watching, you got 3 minutes before you have to get out of here.
Yeah, those are the error, right? So the first one would be like the 99th percentile.
Actually, I think what that means
Because
is,
that looks like an alpha to me.
yeah, it's probably an alpha over 2. Why don't we not do that? And why don't we kind of bring this to close? Let me tell you what Linda has done. I think Linda has done a wonderful job of talking about the Z table. But now I'm going to talk for a while about the X side, and I'm going to show you how we do this. So so Linda, thank you. That was a wonderful job as always, and you have a good meeting. Okay.
All right. I'll set you
Now
up with the PowerPoint before I go.
okay. She's taking good care of me. That is good. Okay, so now I have these PowerPoints, so I'm going to go. They say thank you, Linda. Now I'm going to go to. Now I'm going to do some X problems. Okay, and so I've changed the channel, not the channel, but I've come to this. And okay, so here, what we want to do is, and I'm reading this to you, so everybody watch where I'm reading, and I will just talk about problem number 23. Okay, now problem number 23 says, and I am reading the directions to you, so everybody is looking at the directions too as I'm reading them. So this says, assume that the random variable X, and you see, by having an X there, that tells you we're in X space, not Z space, yes? So we're in X space, and we remember that in your table, the mean is 0 and the standard deviation is 1. But in the X space, the mean is some number mu, and the standard deviation is some number called sigma. So now I'm reading a little bit more. I say, okay, so assume that X is normally distributed with mean of mu equal 50. So you see we have a number now, and that is 50. So we know what mu is. It is 50, and the standard deviation is 7. Okay, and so I could draw a picture of X space with that, and that would be that. And in fact, I got to figure out how Linda drew that because my drawing stuff is not. Maybe I have to pick a color here. I don't know. Okay, so I'm just going to try to draw with what it said there. So I'm drawing a picture. Can you guys see my curve there?
Yes.
Great. Okay, wonderful. Now this is X space then. So this is what X space looks like. X space is, I don't know why the hell I couldn't make this work before, but anyway, this is what X space is. And so we want to know, now what was the mean of X? Well, the mean was 50. So in the middle, we have 5, 0. And we know that sigma, the standard deviation, is 7. Okay. And what they want us to find is, what's the probability that X is bigger than 35? Now, look at this. This is where 50 is. So 35 is over here. And they said, what's the probability that it's bigger than that? And so I'm scribbling in here. That's the area that I am trying to find, is that one. Okay. It's bigger than 35. Okay, now I don't have tables for X space, so what I have to do is I have to use my Z table, and the way I get from X to Z and from Z to X is the Z transform, or that Z equation. So I'm going to say that Z, I guess I have to do that again. Okay, so Z is equal to X minus mu all over sigma. Now I'm plugging in numbers. X is 35, class, right? X is 35. So that is 35 minus the mean. And the mean is 50, 50. And this is over sigma, and sigma is 7. Okay, so this is going to be 15 over, actually it is minus 15. Minus 15 over 7. And I'm going to do a calculator on the side here. I think I can do a calculator on the side. We'll see. So I'm minus 15 over 7. It's, let's see, it's, yeah, it is. There it is. You can't see it probably, but that's okay. And where did it go? I have to stop. I'll tell you what. Does somebody out there have a calculator? What is 15 over 7?
15 over 7.
So it's 15 divided by 7.
2.14.
2.14. Thank you so much. And so that is 2.14. But you see, this is Z. So Z is equal to, now actually, class, this is, yes, I agree, Amber, it is negative 2.14. And I wasn't trying to, okay, so it's negative 2.14. So that means that this picture corresponds to the following picture in Z space. Now we figured out that that was 2.14. So what I'm going to do is I'm going to try to erase this, and the eraser is up here. And by golly, maybe I'm just remembering it's minus 2.14. Yeah, that's erasing good, I think. Okay, so I'm drawing another picture now. But now it is minus 2.14 in Z space. So here's the picture I'm looking at now. And I'm just memorizing that number. Okay. This is kind of a mess erasing all this. But anyway, here is now what the picture looks like. I'm almost finishing erasing. So you see this area is the same as, so I'll go up here and I won't have the eraser anymore. I will have the chalk. And so I'm drawing the, and I don't know why that's not showing up good, but anyway, this is in Z space, and this is minus 2.14. And I'm trying to find this area. Now I hope everybody can see, and it doesn't show up very well, at least on my screen, but I'm having the corresponding area because I told you this was an area preserving map. So now the problem is, let's just find what is the area on this side if this number is minus 2.14. Now I want everybody to try to do that, and I'll do it as well. Okay. So everybody is doing their table and they're going there to do it. And I'm going to go back to find my table. It's not that table, it was negative 2.14. Hopefully you're with me here. So it's negative 2.1. Here's 2.1, it's 4. Okay, and so it's this number right here. It's 0.0162. So I'm going to do that as 0.0162. That's 0.0162. But you see, that was on the wrong side because this is telling me what the area is there. So I have to subtract this from 1. And again, you can use Excel to do this. but I'm going to do this the old-fashioned way. And so what I'm going to have is 8. I'm going to have 3. I will have 9, and I will have 9 again. And so the answer to this problem is 0.9938. And I guess I'm going to pause and say, do people have, and let me just describe what I did again. Okay, the problem was in X space because it told me I was in X space. So I have to figure out what is X. X was 35 in that problem. What is mu and what is sigma? And mu was 50 and sigma was 7. So we figured out that, so we used the z equal x minus mu all by sigma. We did that calculation and we said, oh, it is minus 2.4. And then we drew pictures so we knew we either had to subtract from 1 or not. But then we were in z space. We have tables in z space. We figure out what it is, and it is an area preserving mapping. Okay? So that is good. Okay? Now, I do know what time it is, so I'm going to just pause and ask if there's any questions. And then I'm going to talk about one more example, and we'll probably take a break then.
Can you just explain why we subtracted 0.0162 from 1.0
Did I?
when we were in the areas?
Yeah, I'm going there. All right, here's what happened. You see, the table tells us this area over here. I know you can't see that. The table tells us this area right here. But from the pictures we drew, and just what it says, is we're looking for X to be bigger than 35. Amber, I'll be with you in just a second. So it's bigger than 35. And that was the picture that I drew here at the top of this chart. And so that tells me it's that side, and so it's here. So since the table gives me this number, I have to subtract it from 1. Linda called that something fancy, but we did something fancy and we subtracted it here. Now that's my attempt to answer your question. I hope maybe I did. Amber, what is your question?
Thank you.
When you drew the curve for negative 2.14 and you shaded it to the right, why did you shade it to the right? I'm a little confused.
Because on this picture above here, the one above that, and that's probably not showing up well. It's not showing up well on my side. But you remember, this is the one when I said, this is telling me, oh, I want to be X is greater than 35. So in this other picture, I had 50 in the middle, 35's over here on the other side. But then it was greater than 35, so I had to shade towards the 50 and beyond.
Okay, I got it.
And the shading is going to work the same way, and that's why you want to draw those little pictures.
Okay, thank you.
Because they are useful. Okay, now, and let's just look at this, okay? And I am mindful of the time. I don't know, maybe we could do one other problem, I suppose. Let's look at doing number 25. Now, number 25 says, find the probability that we are less than or equal to 45. Now I'm going to erase a bunch of this stuff. I think we have time to do this one, so I'm going to go back to the eraser. Amber, I lowered your hand because I think you were okay with that. Okay, so damn it. Come on, Jim. How come it's not doing that? I want the drawing, not the brush. Okay, so I'm going to draw it just over here. So this is X space. So it's like that. Now you all remember that 50 was in the middle. So 45 is over here. This is 45. And I want to be less than 45. So it's that area that I'm going to be doing. And by the way, that is kind of cool because that's actually the area that is in my Z place. But I have to do Z things now, so I'm going to erase some of this business. Okay, so there we go. We're erasing things. That's good. So we need to use the Z transform again. So we're going to say Z is equal to X minus mu all over sigma. Okay. All right, so, okay. So this is x minus mu over sigma. So the z-score that's associated with this, I'm going to get my chalk again. So this is z score is equal to, the x was 45, this is minus 50, and this is all over sigma is 7. Okay, now this is going to be minus 5 over 7, and somebody tell me what 5 over 7 is. I know it's going to be negative. Five over 7 is 0.71. Okay, and so we're going to call that negative. Now this is z, so z was equal to negative 0.71. So that's what I'm going to look up in my table. So I'm going back to my table. Negative 0.71, I have to go back to my table. It's not that one, it's this one. And negative 0.71, that's down here. 0.71 is this number right here, and that is 0.23. That looks like 89 to me. So the answer to that problem is 0.2389. Okay, all right, so let's go back. And again, I do know what time it is, so I'm going to dismiss you soon. But oops, damn it, it's supposed to be the eraser. I'm sorry. I think I really am hungry. I'm swearing and everything else. Okay, so we're starting to erase this, but let's look at another problem. We're not going to solve this problem because we don't have time to solve this problem. But look down here at problem, I'm just going to say problem 30. Problem 30 is the area between, yes, I am hungry. Okay, so I go down here, and I get mean when I'm hungry, I think. Okay, so I get down here to problem 30. This is the area between 40 and 49 in X space. But Linda did a problem a little bit like that in Z space. So this problem is going to be the same thing, except you're going to take those numbers and you're going to move them from X space to Z space, and you're going to calculate it over there. Now, we didn't get quite as far as I wanted to tonight, but that's okay. We're doing just fine in this course, okay? So we're pretty much done. I'm about ready to dismiss you. I'm just going to ask, is there any quick question? Let's see. Can someone give me the last answer? I don't remember what it was. Yeah, you can. You got slides. These are slides that I gave you. And so they're there, and the book has it in there, but there's a whole bunch of problems here that you have. So, the answer to that problem is, yeah, you got problems on the slide, and you can do those. And I'm sure Linda's going to be doing these in GSG whenever we have GSGs. You can always come to my office hours if you want to, and things like that. And some of you, probably about 0.25, will, maybe buy the book. You don't have to buy the book. My notes are pretty good, actually, okay? Now, okay, it is important that students be safe over Labor Day. Everybody knows we don't meet on Monday, but I'm going to be doing math. You might have videos showing up on Monday and things like that, but we'll continue working, okay? So be careful, and time is precious. Each day must count. Do the math. It will make you strong. Take care, and I need to stop the thing so Linda can post this video someday. So I'm stopping the recording. Yeah, you guys have a good day too. Be safe. And I got to figure out how to stop this.